Hey guys, George from SoundTraxx here, and today we're going to talk about dynamic braking effects with non-dynamic brake equipped locomotives. Now, many of us diesel modelers have a collection of dynamic brake equipped locomotives and models, as well as non-dynamic equipped locomotives and models. Now, when we're running these together, we want to get a realistic, true perspective on what happens. So let's first examine the real railroads and see what happens when they apply their dynamic brakes. Now, first off, as we've talked about in the past videos, when the dynamic brakes are applied, the prime mover is first affected. It'll either drop down to idle, as in the case with most EMDs, because if you're riding the brakes, you're typically not needing to add extra fuel to the diesel engine that's pulling the traction motors. The other options are you can go to notch 4, which some of the railroads did, such as Southern Pacific, or in the case of the Missouri Pacific, the few that they had actually would go to notch 4. And the reason for that was to make sure that the main generator was generating enough electrical energy to keep the traction motor blowers running. And that pushes air across the traction motors to keep the traction motors from overheating during the dynamic braking process. Now, the third option is to ramp up to notch 8, because in some cases, early GE and Alco, the dynamic brake fans were mechanically driven by the crankshaft. And so in order to maintain maximum amount of airflow, your prime mover would notch up to 8. And then your fans would kick on. The fan sound will turn on as your prime mover is adjusting accordingly. Now, when we're talking about non-dynamic brake equipped models, what happens when those go into dynamic braking? Well, there's no dynamic brake fans, so there's no fan sound, but the prime mover in this case, when attached to a consist of dynamic brake equipped locomotives, the prime mover would drop to idle. Because again, there's no traction motor blowers to run because there's no dynamic braking going on. And second, there's no need to be pressing the gas pedal or essentially ramping up the diesel engine when the locomotive is running. So to mimic this properly, this is where Tsunami2 really shines, because we can take our dynamic braking effects that we've talked about in the past, where the prime mover in this case will drop to idle. We can adjust each sound volume individually. So using CV133, we can take the dynamic brake fan volume and set it to 0. Then we'll take CV116, which is our dynamic braking rate, and we will apply that to match that of all of our different locomotives. So that way, when you have this locomotive in your consist, you're going to get a very realistic effect. Now let's take a look at it now. So now we're going to press F4 to go into dynamic braking. You're going to hear the prime mover drop to idle. Now we're going to press F4 a second time so that the dynamic braking high and the braking rate actually take into effect. Now you can see the locomotive slowing to about 7 to 10 miles an hour, and we'll maintain that until we release the F4 dynamic braking. Now after we get to the bottom of the hill, we release our F4 dynamic brakes. And you see the dynamic brakes released. Now the prime mover notches up and the locomotive starts to move back at normal speed. So now that you've seen how Tsunami2 can mimic the work of a non-dynamic brake equipped model, I hope you implement this into your railroad operations and have more fun with your Tsunami2.